Hello again. Today we will try to deploy some data storage over Kubernetes, uh, but we have to ensure that data persistent over this container. Why this is a problem? Let's take an example. Let's consider that we have a container, and this container has an important folder. This importance in terms of data. Like this container may be MySQL container, and this folder may be the folder in which table data are stored in. So if this container goes down, this may be because of failure, because of service maintenance, because of we manually shut it off to change some settings, to update our system. The container is get deleted, and all the folders in it is lost, and the data stored in this folder get lost also. So does replica solve this problem? No, because replica is generated from the same image, which means that the folders in this replica are reset to its default, and the default values will be an empty folder, which may be no tables, no data on it. So in terms of data, how we can solve this problem? This problem can be solved by using what we called persistent volume claim. Persistent volume claim is like an external storage bot in which important folder will be stored in. Like this, we will move our important folder from the container to the PVC, persistent volume claim, and each container will have a link to this important folder. So when this container is writing or reading from this path, it actually read and write from PVC, not from within the container. So if the container goes down, nothing will happen because the data is stored in another place, and the replica, when it goes up, it reads from the same folder, so it will read the same data, and the data will be persistent here. So does this solve all our problem? Actually no. Um, because if the container has data in its memory or cache and didn't write it yet into the folder, and it goes down, this data will be lost, and this will be the responsibility of the user to check, maybe with acknowledgement, that the data that is committed to the container is stored or not, and if the commit is not finished, it's not correctly done, the user have to submit it again, and this is done normally with MySQL. So we have to provide two YAML files for each app, one for the PVC and one for the app itself. To do this, let's check our GitHub repo. That is the repo for this milestone, and you will find in it a folder called GKE, and within this folder there are 5 files. 4 of them are YAML files, 2 for each data storage. For example, for MySQL there are MySQL PVC, which have the configuration of the persistent volume claim that will use for MySQL, and another for the MySQL app itself. Let's check that for PVC. In PVC, this is the type which we are speaking and configured here is persistent volume claim, and has a name of MySQL volume claim. This name will be used in the app to map important folders and directories here. It has an access mode of read write once, and has a capacity of 10 gigabytes. Both of them you can change it, adjust this is like an initial configuration, and you can change it uh, to fit your app. So what is our app? Let's go back and see MySQL app. So in MySQL app, this is the first part, which is the service which give IP to this deployment, and after this is the deployment itself. That is a part of the deployment, and in this deployment we have only one image from one container from one image, which is MySQL server, and have some configuration, and this configuration is like putting passwords, setting password for the root as password, and creating a user, and this user will, its name will be user, its username, and its password will be SOFE4630U, which is your course ID. So that is how we will connect to the server using this username and this password, and also to a default database, which is MyDB. So if you can see here, this is configuration of the server, and the important path within this MySQL server is the path which is the table and its data is stored, which is root var, library, and MySQL. And this path will be mounted to an external volume, and the name of the mounting is MySQL persistent storage. And here is the description of MySQL persistent storage. MySQL persistent storage mounting this folder to MySQL volume claim. And what is MySQL volume claim? It's here. So MySQL volume claim is only this configuration. So to install this, we have to apply PVC first, and then apply this app. The same will be done for another data storage called Redis, which is KV data storage. And for Redis, we will have two files, the PVC for it, which is called Redis volume claim, and the app for it, which have the same structure, the service that provide an IP to this deployment, and the application deployment, which has only one container from Redis image, and has the same password, which is SOFE4630U. Also, it mounts the important path within this image, which is root data, to using Redis persistent storage. And what is Redis persistent storage? It is just mapping to Redis volume claim, and that is Redis volume claim. So to install or deploy this over Kubernetes, we have to apply this YAML file first, then apply this YAML file next. So let's go to our Google Cloud. And here let's clone this repo. I go here, git clone this repo, and then if we listed all folders and file, we file a folder with the same name as repo, we can change directory to it, and we'll find two folders within it, GKE and Python. So we'll change directory to GKE, and we find our 5 files. So first, we will apply MySQL BVC. So before doing this, let's go to Kubernetes CTL and get all BVCs deployed now. So now authorize it. Okay. There are some from before, so let's delete them before we start. Okay, just I clean some things, clean up previous work from here. You don't have to do this in your console, because you didn't you should have none of those. But let's start by MySQL app.yaml, delete it, and also Redis. And then we'll delete the BVCs. Okay, that is some cleanup, and you don't have to do this. You should, when you are getting your BVC, you should find none of that. Now what we'll do, we'll try first by applying MySQL BVC. So apply by force over Kubernetes CTL. So Kubernetes CTL apply by force the MySQL BVC YAML file, and if we just repeat this command and get the BVCs, we will find a new MySQL, and it's age in seconds. It's just deployed, and after this we will apply the app, and when we apply the app, we should find like a pod installed. So if we get pods, we'll find there is a pod with a name MySQL with some of random characters after it, and it is creating right now. Now it is running. I repeated the command again, it is running. And if we check the deployment, there is MySQL is deployed right now, and it is working. And if we check the services, this is MySQL and has an IP like this. So now I applied I just apply the BVC first, then apply the app, and check that everything's okay, and everything's okay. See you in the next video.